Hello everyone, welcome you all in this course welcome you all in this doubt solving session for design of farm machinery NPTEL course. Today we will discuss week 9, which is mainly related with the sprayer part, and here we will be covering lecture from lecture 41 to 45, and we will discuss the uh, previous year questions of this week 9. So let's start the session. First first thing uh, related to a sprayer is the types of pump, because the pump uh, is so the first thing which we will discuss in this session is regarding pump, because pump is the driving unit which is used to deliver the liquids or pesticides through the nozzle in the field. So there are two types of pumps. First is positive displacement pump, second is centrifugal pump. uh, what happens in positive displacement pump is that the discharge of this positive displacement pump does not depend on the pressure. Suppose on x-axis we have pressure, system pressure, and on y-axis we have discharge, that is Q. So whatever will be the pressure, our discharge will be constant, and this is for positive displacement pump. And in centrifugal pump, here what happens when the pressure increases, discharge suddenly drops. So from here we can see that uh, this positive displacement pump can be used for low pressure as well as high pressure, and centrifugal pump is mainly used when the pressure is very high, and it is not when the pressure is very low, and it is not suitable when we need to use in high pressure. And uh, next thing is for positive displacement pump, it is mainly of three types. First is piston pump, second is rotary pump, and third is diaphragm pump. In detail, we will discuss this all three pumps and centrifugal pump also. So piston pump is generally designed uh, like all we have seen a piston. Suppose this is piston, so it will reciprocate in this direction, and at the same time, the liquid, suppose it will move in this direction. So this is a typical example of piston pump. Here, regarding piston pump, we can see that it is well suited for high pressure applications such as high pressure orchard sprayers, and it is multi-purpose sprayer designed for both high and low pressure systems. Second thing is second example of positive displacement pump is rotary pump. Here, what happens? How the how the liquid moves is that we have a rotary housing, we can say, and inside that we have an eccentric housing where too many rollers will be there, and it will be given motion. So during that, what will happen? It will go in one side, and so it will be uh, getting closer to one side, and there will be a space in at the same time there will be a space in other side. So liquid will move in this direction. In one direction it will go, and in one direction it will exit. So this we can see that this is a rotary pump. And diaphragm pump, what happens? We have a diaphragm type thing, and whenever it moves up and down, the liquid will go in this direction, and it will go up and down. So these are the three examples of positive displacement pump. And what happens in diaphragm pump is that they are becoming widely used as and are available with flow rate of 19 to 23 liter per minute and pressure up to 3.4 megapascal. So, Jigyasa, when did you join? Like, did you see those pump definitions? I just explained piston pump, rotary pump, diaphragm pump, and centrifugal pump now. Am I audible?
Yes, sir. Yes, sir.
Hello.
Sir, you are audible, sir.
Am I
You're
audible now?
audible, sir.
Okay. So one more person will trying Mridula. Yes, later. So uh, I have just explained piston pump, rotary pump, diaphragm pump. Uh, so do I need to explain it? There are two types of pump: positive displacement pump and centrifugal pump. Positive displacement pump, the flow rate does not depend on pressure. And in centrifugal pump, when the pressure increases, discharge decreases. Piston pump and rotary pump and diaphragm pump are there. Piston pump generally it is suited for high pressure applications, and rotary pump we have seen that I just made a diagram and I was saying that it has a slotted rotors that rotates in an eccentric fashion. Diaphragm pump they are becoming widely used and are available with flow rate of 19 to 23 liter per minute and pressure up to this high pressure 3.4 megapascal. And in centrifugal pump, they are suited for low pressure only. So they are suited to equipment such as air pass display and aircraft display for which high flow rates are needed. You can see that at low pressure, its flow rate is high. So they are suited when high flow rates are needed and are required and required pressures are relatively low. So after this we will solve two questions. Then we will move to next topic. So from that discussion we can solve this question that regarding piston pump, diaphragm pump, centrifugal pump, and rotary pump. So piston pump will match in which column? In which row? So, you are audible actually, yes. So you can discuss. So piston pump.
Sir, one will be well suited for high pressure application.
Piston pump, yes, it is well suited for high pressure application. Diaphragm pump,
Diaphragm will be becoming more widely used for pressure up to 3.4 megapascal.
centrifugal pump, it is not well suited for high pressure applications.
And
And
rotary
rotary
for
pump.
eccentric housing.
So A, B, C.
Sir, I have a doubt in this question that for 2026 assignment, in first option it is given 1C and 2D, 3B and 4C again.
Just hold this this week assignment, week 9.
Yes, week 9 assignment. First question, this is there, but
I'm
the
really
option
sorry.
is 1A is not there. 1C is given.
Here it is 1C.
Huh.
This C option is there correct or A is correct, but this is changed.
No, no, sir, this option is only not there.
Oh, this option is not there.
Or else I'll cross check and let you know.
Okay. When is the last date to submit this?
25th.
20. 20?
25.
25. Okay. Okay, second question. So on the boom of a spray, the nozzle having spray angle 80 degree are spaced 50 centimeter apart. The height of a spraying that will give 100% overlap. Okay. Was this question there this year?
So tan d by 8, that formula we will use.
So what will happen is that nozzle is spraying from suppose this here on the boom of spray, it is making an 80 degree spray and it is 50 centimeter apart. So the height of the spring that will give 100% overlap. Means one is here, and second nozzle is here. So what is 100% overlap means is that 100% overlap means at this height, suppose at, at this height, if it is being a spread, then there is no overlap. And we say 100% overlap when this 50 centimeter matches with this overlap. Means this will also become 50 centimeter. So this will be achieved at what height? Means this height we need to know. So this height and this 50 centimeter and this will become 40 degree. So this 50 by h is equal to 1040 degree. So h will become 50 by 1050. So what we will get 50 by 1050 is I guess 60 degree. It is 60. So height will be 60 centimeter. At this height we will get 100% overlap. This was there this year.
And in case of overlap 50%, how the same we will do, no? The 25 centimeter will take.
Okay, in case of 50% overlap, what will happen? This 50 centimeter at this some spacing will be there at which this spacing will become 25 centimeter. Means 50% of this 50 centimeter. So that is 25 centimeter. So this is 25 centimeter. Now you need to know in that case what is this whole length. Like this whole distance you need to know. So this is supposed to be 5 centimeter and this 25 will be left in both sides. So this will become 12.5 and this will become 12.5. Are you getting?
Yes, sir.
So this length will become 25 plus 12.5 and that will become the perpendicular distance of this triangle. So 25 plus 12.5 that is 67.5. Sorry, 37.5. So this height will become h is equal to this 37.5 by 1040. This is for 50%. This height will be there. This question was there this year.
Yes, sir.
Okay. So next thing is droplet size determination for fluid item. So for droplet size determination, what are the parameters? Those are BMD, NMD, uniformity coefficient, droplet density and volume contributed by the droplets, drops of all sizes. So for doing the droplet size, determining the these parameters, what we do, we will place water sensitive papers on the plants. Suppose mainly it is placed at seven different places. Like suppose this is one plant. So water sensitive paper will be placed at top and its upside and downside. Then middle, top side and bottom side, and at the lower part of the plant, top side and bottom side, and one will be placed at ground. So mainly this 7% will be at this 7%. This water sensitive paper will be placed, and the spraying operation will be done. So after that after that spraying operation, we will collect, means all these water sensitive papers are collected, and it is scanned and it is given in a software, like Fiji software is there, that is that is there for image analysis. So what that this software does is that it converts those water sensitive paper into binary images, and it will tell that at what spot, suppose the this is the photo given to the software, and it will then tell that, at, suppose this is one droplet, it will tell that at this spot this is one diameter, means it will tell the spot number, and it will tell that actual diameter is that. So suppose it will tell that one droplet is there with diameter this, one droplet is there with diameter this. So all the number of actual diameters will be shown by this software in increasing order. So what we will do, like this is the work of software. Now we will, what is done is that, uh, suppose 52.82 diameter, in access it, we will count that this diameter is there for how many droplets. Suppose 27. So then next diameter is, then 22 droplets are there, which is 62.60.21 diameter. So likewise, this is the arrangement for number of droplets which has same actual diameter. Now in next step, what is done is that this number is how much percentage of the total number of droplets. Suppose we will add this 27 plus 22 plus 15 plus 14, and we will get some summation of this number, summation of these numbers. So it will suppose come it is coming at 150. So 150, 27 is how many percentage, how much percentage of 150? Suppose it is 12.86. So next to 22 is how much of that percentage, then 15, then 14. Likewise, it will be done for whole data, and at the end it will be very less. Now cumulative percentage of that number is done. So first will be 12.86%. Now 22 number of droplets will be, now it will increase and it will go up to 100%, because that will that is cumulative percentage. What this 23.33 means is that next 22 droplets are there, means below this 62.1, our number of droplets are 23.33%. So likewise it will reach to 100%. So this is cumulative percentage of number. And next thing is calculation of volume. So with volume we have a formula. If this is a diameter, suppose this is the diameter for a sphere, what is the volume formula? That's something 5 by 6 d cube is there. Volume of surface, volume of a sphere, that we will use, and we will get this volume. Now next thing is, this volume is how much percentage of the total volume collected. Suppose this is also coming, this is also coming, suppose this is also coming something like 200. So this, now this 2.08 is how much percentage of this 200, that is 0.49. Likewise it will again, no, that is 0.19, 0.23, and in next column we will calculate cumulative percentage volume. So this will reach to 100%. Now this diameter we will keep in y-axis, and cumulative percentage we will keep in x-axis. Now we will do cumulative percentage for number. This is for number and this is for volume. And one graph will be made, and one best fit equation will be derived from this graph. Suppose this is the graph for VMD, this is the graph for VMD, and this is the graph for NMD. This is the curve for NMD. So for this our exponential equation will come when generalized. This equation will fit in NMD and this equation will fit in VMD. Now this x-axis it will put at 50%. So this is x-axis is this one. So at 50%, so at this point, at 50%, we will put that value in this equation and y value will come. So that y will become the volume median diameter. And in this equation, it will become number median diameter. So this is the procedure to calculate VMD and NMD in field condition in real time. Similarly, like this is explained same thing. This is the volume formula, pyrolysis, DQ, and number of droplets. So suppose this is one graph. Just now I explained same thing is here. So what if you someone will ask you that what is VMD and NMD? This I told you the procedure that how to calculate VMD and NMD, but what actually that number is? Can you explain? Yes, sir.
So it is the mean of the numbers. Volume will be greater than that of the VMD is always greater than NMD. From
You're
if
taking a
we
relation. You're taking just a relation between VMD and NMD. That VMD is greater. And I'm asking that what VMD actually mean, what NMD actually mean, and why you said that VMD will become greater than NMD. These three things. Can you explain?
so it is the average of the number of droplets that are there, like NMD.
Hmm, I'm explaining it. What VMD actually means is that we just now seen that it is 50% of the value of that cumulative percentage. So what it actually means is that you are suppose you are arranging the volumes. Suppose for smaller diameter this is the volume. Just I'm giving one example. Next volume is this one. Next volume is for next volume for next droplet volume is this one. This is just representing the suppose quantity. Next volume is this one, and next volume is suppose this one. So so how many number of droplets are there? Seven number of droplets are there. And volume median diameter is that diameter. If you are arranging all these if you are arranging all these diameters in arranging in increasing order, so one diameter will come where where below that all the diameter will be uh, means below that diameter those volume suppose v1 and after that diameter volume will also become v1 means that diameter right side of which and left side of that volume the volume is same. Suppose at, in this arrangement, suppose this volume if we take, so below this diameter we have suppose V1 volume and after that diameter V1 will be there. So this will become VMD. This diameter will become VMD. We are getting.
Sir, once again, please.
In this arrangement, if I'm asking that which diameter below which diameter the volume is same and after which diameter the volume is same. Suppose this is all volume. So if this diameter if we take this is the diameter below which the volume, if we add, this will become equal to this amount. I'm just taking a case that this will become equal. Suppose if you add this volume, this volume, this volume, this volume, this will become equal to this volume. Then this is the diameter of volume, diameter of droplet, below which we have one volume, and below after which we have one volume, and that is equal. That is the actual meaning of volume between diameter. Are getting?
Yes, sir.
Okay, if I'm explaining NFD, that will become more clear. Now what here you can see is that we have this 1, 2, 3, 4, 5, 6, 7 number of droplets. So NMD means number of droplets below that diameter is equal to number of droplets after that diameter. That that number, that diameter will become, that is one diameter below which all the droplets diameter, the number of all the droplets is equal to the number of droplets after that diameter. Suppose in this case this is very clear. Like this is the diameter below which there are three number of droplets, and after this there are three number of droplets. So this is NMT. This is number median diameter. You're getting?
Yes, sir.
That is the case with that I'm explaining for VMD. Suppose this is VMD is one diameter. The VMD is again one diameter. VMD is one diameter below which the volume is same, below which the volume is there, and after which some volume is there. If that amount is equal, so that diameter will become volumetric diameter. So if we are adding this volume, this volume, this volume, this volume, this volume, and that is becoming equal to this volume, then this diameter is our volumetric diameter. Getting? This is dividing the spread of droplets into equal volume.
Yes, sir.
You're getting? Or it is becoming complicated. I'm explaining in very detailed that you will not get it like in books, that this kind of explanation is not there. So from here you can
Understood.
from here you can conclude is what you just said earlier, that VMD is greater than NMD. So that is not always the case. If if this volume, this diameter would have been of same diameter, then this NMD will become equal to VMD. If suppose all the diameters are of same diameter droplets are there. So its number NMD will become equal, and VMD will also become equal. Means this side volume will also become, this side and this side volume will become equal. So in that case, NMD is equal to VMD. But that is not always the case. If you are arranging it in increasing order, so too many droplets will be there in left side, which needs to be added to become equal to the volume, to become equal to that side, this side volume. So VMD becomes greater than NMD in practical condition. VMD becomes greater than NMD. This is the explanation. And here one more concept comes. You can see that here 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 this thing where all the droplets are of same diameter. Here this is called uniformly distributed. Like, so one more concept comes here is uniformity coefficient. So what you can see is that when VMD is equal to NMD, means this type of spread is there, then VMD is equal to NMD, means uniformity will be equal to 1, means VMD by NMD will become 1, means it will become same. And in general case, what will happen? VMD by NMD will be greater than 1. This is normal case. If the more it is from value 1, the more non-uniform distribution is there. That is the concept here. So this is regarding median diameter. This is one diameter below which and after which, if the volume is same, it is called volume median diameter, and if uh, below that and after that number is same, it is called number median diameter. So second thing is mean diameters. Mean diameters are the arithmetic means which we are studying since. Like if we are adding all the diameter and we are dividing it by number of diameter, sigma ni, it will become arithmetic mean diameter. If we are adding all the surface diameter of all the droplets, means sigma ni by di square, it will become surface mean diameter. If we are adding all the volumes of all the droplets, this volume, this volume, this volume, all the droplets, all the volumes, if we are adding and we are dividing by number of droplets, that will just become volume mean diameter. It is not one diameter below which and after which. That is not the concept here. It is just an arithmetical volume. You are adding all the volume of all the droplets. This volume of all the droplets you are adding, and you are adding a number of droplets. That is volume diameter. And shorter mean is also one concept which defines some kind of a spreadness. If it is the division of volume mean by surface mean, means D30 by D20. And next is percentile diameter. D V 0.9, D V 0.1. What it means is that D V 0.9 means V represents volume, and 0.9 means more 90% of that diameter. Means 90% of this diameter volume greater than this diameter will be 90%. Suppose this diameter is suppose 132 micrometer. So above this diameter, the volume of the droplets will be at to 90%. This dV 0.9 means. And if it is n written here, if it is n, means after this 90% of droplet is of size, means 90% of droplet is 90% of number of droplets will be greater than 132 micrometers. So this is the percentile representation of diameter. This is median representation. This is mean diameter. So mean diameter, droplet diameter, we can express using one generalized
Sir,
equation.
there's a doubt. Sir, in that flowchart, there is written DV 0.9 and another is DN
Wait,
0.9.
one second. हेडफोन में आवाज नहीं आ रही, एक बार ट्राई कर चुकी हूँ। 6 से 7 का बात है, रोज तो ले रहे हैं क्लास में अभी। रोज का मंडे का बात है, मंडे का 6 से 7। हम इसके तो हम इसके तो अनऑफिशियल में ले रहे हैं, 6 से 7 में हमको क्या पता था। 1 घंटे का तो बात है, आप लाके वो कैसे कर रहे हैं। वीक में 1 घंटे का क्लास हो रहा है, उसमें आप ऐसे 1 घंटे तो हम अभी क्लास हम लिख हमको अगर लिखना है तो हम अभी क्लास उठा के बीच से कैसे जाए, अभी बीच से कैसे सब कुछ लेके जाए। तो आप तो बीच में ही बोल रहे हैं ना, ये क्यों ऐसे करो। हेलो। हेलो।
Yes, sir.
हाँ, what we were discussing, हाँ, you were asking me about
Sir, the notation in DV and DN. So I was asking the difference like DV 0.9 and DN 0.9.
here. It is related to number, it is related to volume. Means 90%, suppose the definition is written here. G V0.9 value indicates that 10% of the volume of a spray is having droplets smaller than this value. So this you think that 90%, 10% of this volume is having droplets smaller than this value and may contain a major part of the remaining 90% of the total volume is having droplets larger than this diameter. So it is related to like whatever it is, this is volume. So 10% is like if it is 90%, so 90% is this side and 10% is this side regarding volume. Is if we are arranging volume like same way we are arranging here. So if we are arranging volume in this manner, so one diameter will be there below which 10% of volume will be there, and below which if it is 90% of volume, then it is dV 0.9. So dV 0.9 value indicates that 90% of the volume of spray is having droplets smaller than this volume. So what you can see is that 90% of volume is smaller than this diameter. Means it is becoming very much towards this side. And if it is 10%, means it is coming towards this side. So what if B 0.9, what it indicates that how fine the droplet is. dB 0.9 value is useful for understanding the fine end of the particle. Means it is going, we are discussing it towards left side. And dV 0.9 is it is characterized to force means closer side of the particle distribution. Clear?
Yes, sir.
Okay. Same is the case for D n 0.1 and D n 0.1. Here 10% of the particle is 90% of particles in the sample are larger than this diameter. So whatever we have discussed, we will solve on numerical. And this here every concept is there solved in this numerical. So for the droplet size data given below, determine the mean median droplet diameters. So for this diameter range, 450 droplets are there. This diameter range, 286 are there, and 145 to 170 20 droplets are there. So midpoint of this diameter will become 32. You just do average. Here it is 457. It is 82. Likewise, in here. So what we can conclude from here is that 32 micrometer diameter is for 415 droplets, and 286 droplets have this diameter and 20 droplets have this diameter. So you will do n into 2. This into this, you will get this. So here this is for arithmetic mean, and this is sigma LI square. We square this diameter and multiply with number of droplets in that class. So 32 square into this one. This is this one. And this is NDQ. So when you are adding this, this will become sigma Ni di. And this is sigma Ni di square. This is sigma Ni di q. And this is sigma Ni. This number of droplets is 104. That is the total number of droplets. So what was the formula for arithmetic mean? First, we need to find all the mean droplets diameter and all the median droplet diameter. So first thing for mean droplet diameter is arithmetic mean diameter, which is sigma Ni di by n. Means sigma Ni is written here as sigma. And for arithmetic mean, we first understand this formula. When it is 1, D10 is arithmetic mean. D10 is arithmetic mean. Means D, this is P is 1 and Q is 0. Means D1 0, 1 minus 0. This is sigma Ni di P. Di to the power P means 1 by sigma Ni di Q. Q is 0. So this will become 1. The power 1 by P minus Q. Yes, this is also becoming 1. So sigma Ni di by sigma Ni is directly D10. Next thing is D20, which is surface mean diameter. So D20 is equal to sigma Ni di square by sigma Ni. Again, Pi to the power 0 is 1. So this is to the power 1 by P minus Q is 1 by 2. So this diameter will be equal to this value. So this is the expression for D20. This one. Similarly, for volume medium diameter, it will be sigma Ni di cube by n to the power 1 by 3. And for shorter mean, which is represented as D332, what will happen? D32 is equal to sigma Ni di cube by, here it will not be 0, it will become 2. So sigma Ni di square to the power 1 by P minus Q is 1. So this is the expression for shorter mean. This one. And volume median diameter, I just explained. Number median diameter, we discussed in detail all these percentile diameters. Now, what we need to calculate is all the mean diameters. So mean diameter, first mean diameter is arithmetic mean diameter, that is sigma, that is D10, which is equal to this divided by this. Sigma Ni di by sigma Ni. Second thing is surface mean diameter, which is D20, which is equal to this by sigma Ni di square by sigma Ni. But here you need to divide it by 1 to 1 by 2. So this by this to the power 1 by 2. 4687184 by 1041 to the power 1 by 2. This is surface mean diameter, and volume mean diameter is this by this to the power 1 by 3. This 438 by 1041 to the power 1 by 3. This will become volume mean diameter, and shorter mean diameter is sigma Ni di cube by sigma Ni di square. We just divide this by this and you get surface shorter mean diameter. Clear?
Yes, sir.
Next, we have just calculated mean diameters and median diameter. For median diameter, what we will do? For 450, this is the number percentage in each class. What does this mean? From where this came? Number percentage in each class. So 450, how many number of droplets are there? For 450, 32 droplets are there. For 32, there are 450 number of droplets. For 32, there are 450 droplets, and 450 is how much percentage of this 32? 450 is how much percentage of this total number of droplets? 1049. So 450 by 1041 into 100. This is the percentage of this 32 diameter. So this 32 diameter will be there. 32, 450. 450 is how much percentage of this 1041? Means 43 percentage is there. 20 is only 1.92%. This larger diameter, this coarser diameter is very less. It is only 1.9, means approximately 2% of percent of diameter is this much force. So for we will now do in 80% means 43, and this 20 this diameter range will become 100%. Means total 100% of droplet will come, and volume in each class is for 32 diameter. For 32 diameter, the total volume is this much, and for this range, this is the total volume. So volume percentage means this is how much percentage of this amount. This is 3.36%, and this is 17.64, and this will again reach to 100%. Total 100% volume is there. Total 100% droplets are there. So this is the final data you will get for median calculation. When this is done, one x on y-axis, you just plot diameter, which is this range, or you need to put this 32, or the average of these two is this. You arrange this diameter, you arrange on y-axis, and this percentage of number to volume. This number will come like this, and volume will come like this. So this is VMD and this is NMD. You fit one equation for both the curves, and you get in terms of x and y. So x is 50% side. Means if you take x as this value 3.36, you will get 32. So what is 50% of this volume that you put at the place of x? You will get what is the volume median diameter. So you put 50 in this equation, 50 in this equation, you will get VMD and NMD. So this is the VMD and NMD calculation. So from there, every doubts, next all questions you can solve from those two things. So next question related to week 9 is given below is an equation for computing the average diameter drop pattern spread. Okay, so you have to match this thing with which diameter it is called. D10 is called
Arithmetic B.
this is arithmetic mean. D20 is surface mean. D30 is
Volume.
volume mean. D32 is certain. So BDCA. BDCA is there. Option D is the correct answer. So next question is whether the following statement is correct. You just read this statement and tell me. The volume of a spray with droplets of diameter less than nm equals the volume of droplets with diameter greater than nm.
It false.
Why?
KMD is greater than number.
The volume of a spray with droplets diameter less than nmd equals the volume of droplet diameter greater than nmd. This side volume is same. One diameter is there. Here one diameter is there, and droplets volume of spray with droplets diameter lesser than this diameter is this side volume, and this side volume is equal. Here this side volume equals the volume of droplets with diameter greater than this. So this is NMD. Both side volume is equal and it is telling that this is NMD.
This is VMD, no, sir?
Yes. So here it will be VMD. So this diameter is called VMD, not NMD. The number of droplets with diameter greater than VMD is equal to the number of droplets with diameter less than VMD. So number of droplets with diameter greater than NMD equals the number of droplets with diameter lesser than NMD. So both is incorrect. So neither one nor two will be the answer. So fifth question is, for a spray with given flow rate and operating pressure, overlapping can be controlled by spacing of the nozzle, height of the spring, angle of the spring, both spacing of nozzle and height of the spring.
Both.
This is flow rate and operating pressure. So it will just depend on the spacing of the nozzle and height of the spring. Next is for applying insecticide or fungicide to field crops. When foliage penetration and complete coverage of leaf surface are required, the type of nozzle used is. Types of nozzle I have not made the slides, but if you have seen the lectures, you can tell which
It's a
type of
hollow
nozzle.
cone.
This is hollow cone. So next is numerical. A sprayer with hollow cone nozzles at a spacing 50 centimeter is operated at a forward speed of 5 km per hour for an average application rate of 200 liters per hectare. Assuming zero overlapping, the nozzle flow rate is liter per minute.
So 0.8.
How how we will calculate this?
So the area we will calculate first, like 0.5 into the 5 km per hour, we will convert into meter per minute, and then to the application rate, and that will be equal to the nozzle flow rate. So we will equate it and we will
Yes,
get the
yes.
answer in
50 centimeter spacing is this spacing and this forward speed. This spacing become meter square per hour, and we have liter per hectare. Means liter per meter square is there. So liter per hour will we can get from there, and liter per minute we can convert. So how much meter square per hour it is covering? 50 by 100 into 5,000 meter square per hour into 200 liters per hectare. 200 meter by 10,000 meter square. We have to calculate in liter per minute, so 1 by 60. So what you are getting 0.83. Okay, this calculation is
yes,
0.83 liter per minute. So next is sorted mean diameter of droplet sprayed with tractor drawn on the sprayer for a total number of 2401 droplet is 186.8 micrometer. This is sorted mean diameter. If summation of surface area of this droplet is this image, the volume diameter of the droplet will be. Sorted mean diameter means sigma NI cube by sigma NI square. This value is 186.8 and sigma Ni is 2041. Sigma Ni is total number of droplets 2401. Summation of surface area of these droplets is sigma Ni square. That summation which we have just discussed about. This summation is equal to 36826178. This is sigma Ni square. We need to know the volume mean diameter. Volume mean diameter is sigma NITI cubed by sigma Ni to the power 1 by 3. This we need to find. So sigma NITI cube we can get from here if you see it. Here sigma ni di cube will be equal to 186.8 into this sigma ni di square. This value. So 186.8 into this much. This will become sigma ni di cube. So 186.8 into 36826178 by sigma ni means 2401 to the power 1 by 3. This is for the median diameter. Calculate this. What you got? 186.8 into 36826178. Did you get the answer?
No, sir, it's not in the option.
It is coming
Sir, C.
142.03. It is coming.
03, yes.
142. So C is the answer. The next question is the volume mean and surface mean diameter of the droplet sprayed with tractor down boom spray is with a total number of 240 droplet are this and this. The shorter mean diameter will occur. So volume mean and surface mean means sigma NI cubed by sigma Ni to the power 1 by 3. This is volume mean diameter and it is given as 142. And sigma Ni and surface mean is sigma Ni di square by sigma Ni to the power 1 by 2 is given as 123.8. Shorter mean diameter means sigma Ni di cubed by sigma Ni di square. You have to find this. So this value is this value. So 1 by 3 you just put it this side. This is cube and 1 by 2 this side. This will become square and divide both. This by this. This 142 cube by 123.8 square. Got the value?
One 186.
186. 186.8. Okay. So 9 also solved. Option answer will be D. So next question is increasing orifice size of the nozzle by 20%. Volume latent diameter. Well, there is one relationship, like section is there with volume latent diameter related to.
B. B.
Okay, we will solve this. And like volume latent diameter with pressure and all, one relationship side is there that I will show in next class. So how volume latent diameter is related.
BMD2 equal to like 2 by 3 P1 by P2.
This is orifice diameter D1 by D2, which is related by relation
2 by 3.
2 by 3. So increasing the orifice size of the nozzle by 20% means second diameter is 20% more, means 1.2 D1. D2 is equal to D1. You just invert this column, BMD2 or BMD1, and it will be same. So this ratio will be same, so it will be 2 by 3. So BMD2 by BMD1 is D2 by D1, and D2 is 1.2 D1. D2 is 1.2 D1. So 1.2 to the power 2 by 3, that is equal to 1.2 to the power 2 by 3.
Sir, 13, like 12.9 I'm getting answer.
It is 1.12. 1.129. So BMD2 is 1.129 times greater than BMD1. This is BMD. So it is greater by 0.129%, means 12.9%. So it is increasing by 13%. So for 10 answer will be B increasing 13%, 30%. So these are the these are the numericals from those lectures, week 9 lectures. Maybe any week, maybe 40, between 41 to 45. So have you seen these numericals? Are you getting all the
Yes,
numericals being solved there?
yes, sir. So one question I have, like one question, not this one, but
One question
the
from
one is for the lectures.
which question it is?
Sir, after this, not this one.
This question.
No,
Four,
one
five
half of
questions I selected for solving in class. So if you have
this
that question,
19 liter something is there. No?
hmm,
19 liter is there. Afterwards, third. Before this question. 19 liter.
in which lecture it is?
Sir, I have actually marked like it is there that half be uh,
Huh?
in the sir some mango, or third question is there.
The mango. 19 liter. 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 19 l No, 19
19
also.
liters for tree. This one.
In a window orchard, the trees are planted 9 to 9 centimeter spacing. The chemical is to be applied at the rate of 19 liters per tree. In spread is normally adjusted to give a reserve of 4 liters per minute at a pressure of 450 kilopascal. As in the spirit to project, the number of nozzles required if one half so it is split for each side, and number of mango trees which can be covered at one time with a tank capacity of 3.4 diameter. So what is the air? Like, uh, some
So
numerical
my
problem is.
doubt is that how, like in the if one half row is sprayed from each side, what we are actually considering in that? Like, sir has actually taken 19 by 2, 19 liter per tree, 19 by 2 sir has taken for calculation, but how is that? Like, why 19 liter? Not getting.
19 by 2, I think you question some modification with the 90 liter per tree is there. So 90 liter will be for one tree.
So if one half row is sprayed from each side, that means that question I'm not getting. So if you can explain.
This is the spray movie and it is spaced 9 meters and it will be spraying 90 liter for one tree. So you are telling like in lecture it is 19 liter by 2. It should be 19 liter only, not 19 by. Okay, I'll see that lecture and I will solve this question in next class. Okay.
Okay, sir. Sir, in assignment one, like assignment this week, ninth week, first question I have shared you the question. The option is missing that one.
One that option is repeated. No? Is one C for option one is repeated. One C and four also C is written there. So you should select option A only because DBC is there. DBC is there.
Others are there. We
Yes.
can select, but
That is actually mistyped by the
and in
NPTEL.
last week's assignment also, sir, that less than 50 degree that was marked incorrect for
Indicate what?
low volume
That
application.
I saw. That I have also complained. You people will get that bonus marks in question.
Sir, and last to last also there was one mistake. Like I have shared that
Uh,
also.
that that made enough quiz was there. Okay, that also I have told to sir. I told him. So what all questions are incorrect, you will get marks for that.
Sir, regarding live session, I wanted to
Regarding
ask
live session, yes.
Wednesday from 3 to what time it will be?
Wait, I'm telling that email came to me also. It is at 3 p.m.
Sir, 3 to what duration will be?
I did this how till the time discussion goes on, it will be there. 3 to 5 mainly is there, but mainly it goes for 1 hour. 1 hour becomes
So we have actually class timing that time. So if my doubts are there, I'll be sharing it in the mail or like
one
how
Google Sheet to will come
able
to
to
you
join.
people. One Google Sheet will come. There you can write post of your doubts and
They
related
have
topics.
told to write in the forum, but forum is not opening only. Like only the announcements are showing in the forum. Like how to where to write or to
That forum is not opening for you. Like,
no only announcement showing, like no discussions or no things there.
that forum, can you share with me? You just say
One second.
you share on my mail. I and this class I solve this question. I'll see that what in lecture what has been done. So in next class we will discuss week 10. So we are ending our class here. Do you have any doubt from this session?
No, sir, no doubts. And they have provided a Google form for it.
That form only I was talking. That you fill that form, sir
Huh.
will get that form. Let's discuss those doubts there.
If we are not able to join also, sir
That
will
later
take
you
decision.
can see those doubts.
Oh, okay, sir.
Okay then, I'm ending this class.
Thank you, sir. Thank you so much.
Okay, bye. So after this, we will again solve a question related to seed drill. And the question is during calibration of horizontal plate planter having 72 cells on a 167 diameter circular plate with sugar beet seeds, 28.75 gram of the undamaged seed, 0.95 gram of damaged seed were collected during 50 revolution of the ground wheel. A 6.40 gram sample contained 556 seeds. The seed plate makes 0.76 revolution for each revolution of ground wheel. So, and we need to calculate average percentage cell fill. Second is linear speed of the cell, and third is percentage of seed damage. So for first part, that is for average percentage of cell fill, we will calculate what is the actual seeds dropped and what is the theoretical seeds. So we will divide actual seed by theoretical seed and we will get the average percentage cell fill. So for actual seeds dropped, the test weight is given, that is 6.40 sample is containing 556 seeds. So 6.40 gram as 556 seeds. And during calibration, we are obtaining 28.75 gram. plus 0.95 gram. So total seed obtained is 28.75 gram plus 0.95 gram. So after adding this, we are getting 28.75 plus 0.95, that is 29.7 gram. So 6.40 gram has 556 seeds. So 29.7 gram will have 556 into 29.7 by 6.4, which is equal to this into 556 divided by 6.4. So 2580, approximately 2580 number of seeds are being taught. And theoretically the seeds obtained will be number of cell into ground wheel revolution into gear ratio. Number of cell into ground wheel revolution into gear ratio. So number of cells given with 72, ground wheel revolution is 50, and gear ratio is 0.76. So multiplying 72 into 50 into 0.76, we are getting 2736 seats. So here you can see theoretically we need to get 2736 seats, and actually we are getting to 2580 seats. So what is the percentage cell fill? Percentage cell fill, it will be 2580 by 2736 into 100. So 2580 by 2736 is equal to 0.94. That multiplying by 100, it will become 94.3%. So percentage self fill is 94.3%. So this was the first part. Second part is linear speed of the cell. Second part is linear speed. For that, we need to know what is the RPM of the seed plate, and from there we can calculate what is the linear speed of the cell. So for this, we need to know what is the RPM. RPM or RPS, that is revolution per second. So RPM will be 50 revolution it is making, and gear ratio is 0.76 divided by in how many seconds it is taking 50 revolutions, so 68 second is given. So rotation per second will become 50 into 0.76 into 68, and this calculation is giving the value 0.558 revolution per second. So this is revolution per second, and we need to find linear speed. For that, what is the diameter given? Diameter is 0.167 meter. So what will be linear velocity or linear speed? It will become pi into d into revolution per second. So pi into 0.167 into 50 into 0.76. We have just calculated what is rotation per second, 0.558. So this value we will get as 0.293 meter per second. So this is the linear speed of the cell or plate. So two parts we have done. Next part is what is the percentage seed damage. So third part is what is percentage seed damage. And for that, mass of damaged seed is given. Mass of damaged seed, we will divide it by total collected mass into 100. So mass of damaged seed given is 0.95 And total mass we have done in first part, it was 0.945 plus 28.75. 28.75 plus 0.95, which was coming as 29.7 gram. So percentage seed damage will be 0.95 by 29.7 into 100. So it is coming as 3.2%. So this was the question related to seed drill which we had left in previous class. And next question is again related to rotary mower. So in this question, a single disc rotary mower has 4 blades and it rotates at 500 rpm. The mower is operated at a forward speed of 15 km per hour. To obtain a swath of 0.4 meter, the minimum required length of each knife in centimeter is asked. So for solving this question, what are the things given in the question? Forward velocity, it is 15 kilometer. V is 15 kilometer per hour, or like converting it in meter per second. So it will become 15 by 3.6, that is 4.167 meter per second. Rotational speed is 500 rpm. Rotational speed is 500 rpm. Swath width is 0.4 meter. Swath width is equal to 0.4 meter. We need to find the angular velocity, that is omega. Angular velocity, omega, it is and for what is the expression of omega? It is 2 pi n by 60. So all the parameters are given here, 2 pi, and n is given 500 rpm by 60. So it will become 2 into pi into 500 divided by 60. It is 52.35. It is 52.36 radian per second. So angular velocity is 52.36 radian per second, and we need to calculate the minimum knife length, that is L. The minimum length required to ensure no uncut strips remain between blade impact. See, it is given by ratio of forward velocity to the product of number of blades and angular velocity. That is L is equal to 2 into V divided by N into omega. And forward velocity is 4.167 meter per second. N is number of uh, N is number of blades, that is 4 blade. So V is equal to 4.167, N is equal to 4, and omega we have just calculated as 52.36 radian per second. So what will be the minimum length required of each knife in centimeter? It will become 2 into 4.167 divided by 4 into 52.36. This we will get in meter and we need to convert it in centimeter, so we will multiply it by 100. So the final answer will become 2 into 4.167 into 100 is equal to 833.4 divided by 4 into 52.36. It is equal to 209.44. So this value is coming as 3.97 centimeter. So here we just saw that length of knife is I wrote 2 into V into N into omega, where omega in radian per second I wrote. So this, if we are balancing the unit, it is not coming. So this formula you can omit it here. So length of each knife, minimum length will be equal to velocity by N number of blades into rotation per second, revolution per second. So here what we will get in meter. So length of knife, we will use this formula. So well, forward velocity we have already converted, it is 4.167 meter per second. 4.167 meter per second divided by number of blades is 4 into rotation per second, it is 500 by 60 RPS. So this will be the final answer. So 4.167 divided by, it is coming as 0.125 meter. So final answer will be 12.5 centimeter. So this is the end of all the questions from vertical conveyor reaper, mainly harvester. So we have already studied all the angles related to threshing harvesting unit, that is vertical conveyor reaper. If you remember, we have studied oblique angle, chip angle, uh, blunt knife, sharpness of the knife. So if I will ask you that what is, if we are given oblique angle of knife as 20 degree and oblique angle of counter shear as 10 degree, and if it is asked that what is the value of clip angle, so what you will tell? So for clip angle, it will just be the sum of these two angles. That is oblique angle of knife plus oblique angle of counter shear. So it will become 20 degree plus 30 degree is equal to 10 degree is equal to 30 degree. So this was a small question which might come in your NPTEL examination. So I hope all the questions we have discussed in this session. If you have any doubt, you can write in the comment section. So if you have any doubt, you can write in the comment section, and we will end this class here. Okay, thank you.